I'm a rising high school senior at Keystone School, and I am a developer advocate intern at TigerGraph, the only scalable graph database for enterprise. Thank you to everyone attending and to everyone who made the first ever K-12 Data Science Conference possible, and I'm honored to be the keynote speaker for this event. First, I'd like to take a moment to reiterate that this is the first ever K-12 Data Science Conference. Isn't that amazing? In 2018, UC Berkeley graduated their first cohort of data science majors, and now in 2021, we're hosting the first ever K-12 Data Science Conference. That's fantastic to me. Data science is the future. It couples statistics, computer science, and mathematics to be used over so many fields, from medicine to sports to entertainment, and so much more. By attending today, you all are here to learn a thing or two about data science, and you're helping create the future. You're being part of the future technology. So that's amazing. To all the students out there, you are the future. And now you're learning about what's going to be in the future. That's fantastic to me. I'm here today to tell you a little bit about my story, how I got into data science, and all of that. So currently, as far as I know, there's no real data science class taught in the K-12 curriculum. So honestly, up until 8th grade, I didn't know that data science existed. Sure, I heard about AI from like movies, about like robots trying to take the world and computers also trying to take over the world, but no movies really mentioned the term data science. So during 8th grade, data science didn't exist to me, and I also didn't know how to code apart from some block programming. Really, when I was in middle school, I had one passion, which was math. So in math, you learn a lot of concepts in school, but what most excited me was how to apply this. I was super into this show when I was in middle school, and it was all about this mathematician trying to solve FBI problems. So one really cool thing they did was he was using like quadratics, which I was learning in Algebra 1, to be able to tell like the trajectory of a bullet to see where it was shot. That was amazing to me. And I think my interest of applying mathematics is really what drew me into programming. In the middle of 8th grade, I started trying out my first ever programming opportunity, first scripting. I was learning HTML. Now, I know there's like a controversy, is HTML a programming language or is it not? You can take your side on that. For now, I'm just going to say, yeah, HTML was my first programming language along with JavaScript. When I did HTML, I looked at W3 schools and I created my first ever program, which was these little robots made out of little boxes. I was so proud of that. And then I was also able to create little BB-8 robots, and I thought that was really fantastic. But I still didn't know what data science was, and I continued exploring different algorithms, different code. Eventually, at the end of 8th grade, I was sitting with two other people, and I was listening to their conversation. Now, they were super into technology, and I didn't know that much at that time. But I remember they were talking about things like data science, like deep learning, like machine learning. I was kind of confused, but I remember one of the people said, data science is really cool, it's also really hard. Now, I took that as a challenge. See, I wanted to be cool, and it was hard, so I wanted to investigate that. I wanted to learn about that. And so my 8th grade and to 9th grade summer project was learning about machine learning, learning about data science, learning about all of that. My first ever machine learning algorithm, my first ever code, was using genetic algorithms to solve the traveling salesman problem. Now, for those of you who are not familiar with that, a traveling salesman is in essence taking a set of points and trying to find the shortest path through it. So think of a salesman wanting to go to these many cities to sell his product, but he wants to take the shortest path through all of that. It sounds simple enough, but once you have more and more points, there's more different possibilities, and it becomes a lot more harder. So the approach I was working on was using genetic algorithms. This was kind of cool because at that time, as a 9th grader, I was learning about biology, and so it was really cool to see data science and biology come together. Now, for genetic algorithms, what it is that I was having each, say, like genome be the set of points, and then I'd have another set of points, and I'd have a bunch of those. And then every iteration, I would have the 2 points combine in some form to create a new set of points. And then I'd have this survival algorithm, which would be, okay, this is how good this set of points is. So what I would do is I would calculate the survival of the batch, and then I take out the lowest set of points, and then continue iterating this. And I did it, of course, in JavaScript, because I was obsessed with JavaScript at the time. Now I recommend Python. And then I put this together in HTML. So it's really cool. You could just click around on the screen, and it would run this traveling salesman problem. You could see all the computations, and I found that super cool. What was even cooler about it was that to calculate the survival, so how good is a set of points, I had to use the distance formula. So that's kind of like the Pythagorean theorem. I was able to apply what I was learning in geometry to my passion, which was amazing to me. So a few months later, I started tackling neural networks. Neural networks, you might have heard it in the news. They're really cool, really powerful. One drawback is explainability, but really what I wanted to learn was the mathematics behind neural networks. So I started off with that. I was watching this MIT OpenCourseWare video, and I honestly didn't understand it at first because it was talking about like partial derivatives. It was talking about this calculus, like 3 concepts. But here I was, a 9th grader. I just finished geometry, and I'm starting on algebra 2. So these are really big concepts for me. What I was able to do was I would go to the computer lab every time during my free time. And since no one was there, I would use a bunch of the computers I had. I'd have one computer which would play MIT OpenCourseWare over and over again. I had another computer which had JavaScript open up so I could like, code anything which I needed to. Another computer had notes, and the final computer had just Google open up if I had any questions, if I had to look up any terms. And I would do that for like a week until I felt like I finally understood a bit of the math behind neural networks. And then I explained it to anyone who talked to me. And then I was able to implement my first little neural network from scratch. But as I continued investigating, it was really cool to see how some of the concepts I was learning was translated into neural networks, the math behind it. For example, I was able to see like E was appearing up in sigmoid function. And that surprised me because I always associated with E to solve those natural log problems. And then I started learning about matrices in algebra too, and I could see how you can use matrices to change like the mini little neural network to be able to compute big problems, which was fantastic to me. Now, a bit into the future, a few months ago, I got the opportunity to be an intern at Futurist Academy. There, John, his first assignment to me was to learn TigerGraph, graph databases. I was kind of surprised. Every time I think of graph, I think of like a bar graph or a line graph, but graph databases are completely different. They're, in essence, a set of vertices and edges put together to model some sort of data. So this is, in essence, connected data. One of my favorite examples of explaining this out is, I'm not sure if you guys are familiar with that Wikipedia game where you start on one page and you click all the links and you're trying to get to another page. It's with graph databases, it'll be much more simpler to do this. So think of each Wikipedia page is a node, is a vertex. And then it's connected to all the other hyperlinks using edges. So if you click on this, you can go to different pages. And using that, you can create a shortest path algorithm to go from one vertex to another as fast as possible, finding the shortest path. So real amazingness of graph databases is that they can be used for deep analytics. And that's really what has drawn me into it. Something else which I learned in Futurist Academy was this algorithm called cosine similarity. Now, cosine similarity is a way to see like how similar two things are. But what was really fascinating about it to me was that it was using cosine, which is something I associated like in geometry, maybe with like triangles, or in pre-calculus with like unit circle, but I never thought that I could see it being used to see how similar to, say, medical articles are. That blew my mind. And then fast forward to now, I'm an intern at TigerGraph. I get to investigate tight graph databases and see how they can be applied to different places. I love just trying to see, okay, how can I add TigerGraph to this project? And I'm really excited, and now I get to speak in front of all of you guys. So if there's anything that I want you guys to take out of this presentation, it's that, okay, while there's no data science class right now, while you don't have access to data science in your curriculum, you should value the math courses you're currently taking. Yeah, the math might seem really obscure and you'll be like, okay, how do I use this? But I'm sure in data science, I see weird things from math appear everywhere, which is fantastic to me. And I think the math that you're learning is a really strong foundation for exploring data science. Second, I want you guys to not be afraid of data science. So from the conversation I was listening into with others, said data science was cool, but it was hard. So since you guys are in a data science conference, I think that means you all are really cool. But then also, yeah, some parts of data science might be hard, but just be able to approach it, be able to tackle it, and just break it down step by step. And then you've got this. Remember, as I said, data science is the future. And all the students out there, all the educators who are helping create this future, the students, you are the future. And your excitement to learn about it is incredible. So thank you so much for coming to this talk. And then if there are any questions, I can probably ask them or answer them before this ends. So what is the MIT Open Courseware? So MIT offers this open courseware platform, which is able to, where you can learn how to, where it just kind of walks through machine learning. And so I believe it was like the 12th lesson on there, and you could learn about neural networks. And it kind of broke down, here's how you create neural networks, and here's how you propagate back towards it. Here's how they learn. So that was really cool. Okay. Thank you, everyone who came, and I hope you have a fantastic time at the conference. Okay, I'm interested in data science as well. Can you suggest a suitable course for me? Let's see. The thing is, I didn't really go through a set course. I would recommend you can also check out TigerGraph if you're interested in graph databases. And then also, there are a bunch of cool courses on Coursera. One of the most popular ones is going to be a Stanford, the one machine learning by Andrew, I don't know how to pronounce the name, but NG. And that's like a really good way of going through the like math, the theory behind it. And then also this summer, I'm going to be teaching a mini course about different tastes of data science, different machine learning. So I can probably plug that in if you're interested. I can add my email into the chat, and you can probably reach out to me, and we'll have that set up around July. So that's the thing. I definitely recommend Coursera. There's also a bunch of Udemy courses you can take, which are more practical. I know that A to Z machine learning is popular, and I took that, and then also A to Z deep learning. So those are some courses you can check out. And then if you guys want to reach out to me, here is my personal email, which you can use. Right? And then What are your plans for the future? So right now, I guess my plans are to, go to college. I'm thinking about majoring in data science or computer science and exploring more of that. I'm not quite sure, but I just really am interested in data science and I want to learn more about that. Do you use algebra or geometry more to code? I would say algebra. Algebra seems to be like at the basis of everything. So you see like machine learning right now, you have a strong foundation of like linear algebra being used. You have like calculus being used. Yeah, and then also kind of as John said in the chat, I will be launching a Udemy course on learning TigerGraph. So that'd be a really cool opportunity for you to learn about TigerGraph. And then also later in this conference, I'll be giving you a overview of that course, almost a walkthrough, and that will be explaining out how to create your first graph with TigerGraph, and then how to create some visualizations on top of it, and so on. Let's see. What is my favorite data set to work with? I will say my favorite data set right now is the Pokemon data set, because that is what I'm going to be using to create my graph with. So if you see that, you can see that workshop later on. I'll be using the Pokemon data sets to create that graph, and then also the course, which is going to launch in Udemy. That will also have the be using the Pokemon data set. I think it's a fun data set to use. Yes. Okay, we have 3 minutes left, so we will be wrapping up right now. What about Minecraft? I think will be a speaker, which will talk about Minecraft later in this event, so that'll be really cool to hear from. Let's see. I think I addressed everything, and then we only have about 2 minutes left for this presentation. All right, so I hope all of you have a fantastic rest of the conference, and I will see you hopefully in some of the future sessions.